So today we're going to talk about a little bit of, for a short time, just a little history of Hadoop, and I guess our entry into that space. And I'm going to cover off as well some of the myths that we often hear from our customers and our partners as we work in this space. And I want to correct some of those myths with you. So let's talk about Hadoop a little bit and what it's done for our customers. We've seen a tremendous transformation in terms of the way that our customers process data using Hadoop. Most of the customers we're working with usually start with either custom-written data stores, they're starting with operational databases, they're starting with data warehouse, and they've run into those traditional problems, the 3 Vs, which we'll touch on again in a few slides, that cause limitations in that sort of an architecture in terms of their ability to handle the ingest rates, in terms of their ability to handle things like unstructured data, tweets, emails, and so on. I think everybody recognizes from things like the Netflix challenge that what we really want to do is bring a lot of data sources onto one platform. Algorithms are important, but they're not as important as data. What you want to do is bring on as many disparate data sources onto one platform as possible. And people who've been doing data warehouse for a while, they recognize this, although they haven't been able to handle the variety and they haven't been able to handle the performance, but they do get the fact that you want to have a master copy, a copy of record, if you will, of your data. We want to have one place to go for reporting. We want to have one place that's real time and reflects the operational history of the company or the organization, allows us to project into the future, represents effectively our dashboard. That's what we want in the corporation. But Hadoop has not typically worked in that model. Now it's added things. It's added that ability to incorporate different types of data, but it's also changed the model a lot. And this is the impression that most people have of Hadoop. It's batch, works in stacks. You've got a bunch of data, you copy it on. Hadoop works like a CD-ROM. Once you put the data there, it's not mutable. You start again, you bring more data on from your data sources. And so you effectively have something that works in a series of steps, but isn't something that's real time. This is the impression that people have of the way that Hadoop works. Another impression that people have of Hadoop is that it's ephemeral. By ephemeral, I mean that the data that you place on the platform, well, you can't really trust the platform. It's complicated, it's difficult, it's also unreliable. That's the impression that people have, that the platform can't be trusted. And if you can't trust the platform, well, then you don't have that place that represents your place of record. It doesn't truly form a replacement for the data warehouse, because that solution has to be a copy of your primary data where you do trust the data source, where you do trust that underlying infrastructure to hold the data safely. And so these two things sort of conspire to create this paradigm. And the paradigm is, let's have lots of other data sources and let's continually move copies of those things over to the Hadoop infrastructure, and then we'll do some analysis and then we'll repeat. We're going to rinse and repeat until we get what we want, but it's not a real-time model. It doesn't act in the way that our data warehouse did before. So let's come back to that data warehouse. We want to have those properties of the data warehouse that we liked. We want to have that ability to have a continual, updated, real-time copy of record of our data. And that thing should continue to be the place from which we do all of our reporting. How did Hadoop get into this state? Where did this impression come from that Hadoop was something that was ephemeral and Hadoop was something that was batch? Well, let's talk about the real-time part. I think all of you, well, a lot of you in this audience have probably had a lot of history with MapReduce. You know how this paradigm works. You bring on a set of data, you run a parallelized map operation on the data, you shuffle things to different nodes, and then you go ahead and reduce that set. You have composable functions that allow you to do continual processing of your data. And of course, we have stacks and stacks of APIs that live above the MapReduce layer now to make this much more functional, much more usable, much more convenient. But underlying all of that model is MapReduce and HDFS. And that architecture was one where you were continually bringing on a set of data, writing it once, doing some batch processing, and then revisiting that. Adding more data, deleting what you had before, but not modifying, not a real-time modality. That's not the way it was designed. And so basically all the early adopters of Hadoop went to this model. This is the way all the code was written. Now, does it have to be this way? It doesn't. And that's why these things are myths, and we'll talk about that. Why don't we want that modality where we're continually bringing data over? I mean, it seems to work. Worked for Google. Worked for Yahoo. Seems to work for them fine. Just keep bringing those copies over, keep crunching them. Lots of compute power seems reasonable. Data's big. That's the problem. Data has mass. There's physics around data. You've only got limited network to bring that data in, and it takes time to do it. It means that whatever view you take of the data, whatever report you run, is necessarily latent. It's always behind where your data sources are today. It also means that if you lose that data source, if Hadoop were to fall over and it weren't available, well, you probably squandered a lot of time getting that data over. You're not going to have to recopy all over again. So that's a problem as well. There's an essential genius to Hadoop that is completely orthogonal to what we've discussed so far, and that remains in Hadoop even as we move on to Hadoop 2. And some of those things involve the automatic parallelization of data processing, of munging of data, transferring of data. This is one of the elements of essential genius of Hadoop. How many years of high-performance computing did we have? How many decades of high-performance computing did we have before we adopted a model, which is one type of high-performance computing, that allowed the everyday person to go and crunch data? It took a long time to figure that out. It took a lot of research, took Google to actually build it, and others to adopt that into the open source community and provide that out generally to the public. But we got it. We eventually got a model that works for crunching data as long as you fit into MapReduce. But that essential idea that we have a tool now that we can all use to crunch data, that continues. We'll talk about how we're evolving beyond MapReduce, but that idea is still very important. This is why we have the first change in data stores in database in decades. Because Hadoop has broken the paradigm. Hadoop has allowed us to go beyond that limited scale of the operational database or the limited scale of the data warehouse and incorporate different types of data sources and go to massive scale. And also, and this is so important to Hadoop, do it economically, right? This is one of the most important things about Hadoop is this is not an incredibly expensive, locked-in proprietary technology. It's something that is affordable, and it's affordable at scale. It's so much more affordable that we're looking at factors of 10 to 1 or 20 to 1 versus traditional MPP data warehouse technologies. If you're a CIO, it's very hard to say no to that. It's very hard to walk away. You've got to look at that sort of a model. It's so disruptive to your current environment. So how is Hadoop changing? Why is this a myth? Well, it's changing all over the place. Hadoop is not one layer. Hadoop is a collection of tools. And for any one paradigm that you're trying to execute, if it's real-time stream processing, if it's search, if it's log file analytics, you're probably doing you're collecting different sets of tools, and you're working at different layers of the stack to get done what you need to get done. And Hadoop, well, it's evolving too as a group of tools. It's evolving in the open source community. We see improvements all the time at different layers of the stack. We see the gaps compared to our traditional data stores and what we have in Hadoop. One of those is SQL. We have 30 years of applications written for it. How do we migrate those over? How do we migrate the people? What's the human interface? So you see adaptation there and things like the Apache Drill project, which MapR promotes. This is an area where we want to bring in full ANSI SQL 2005 into Hadoop and be able to allow those people and those applications to continue working. We also see adaptations in the Hadoop structure itself so that MapReduce becomes factored out of the existing code, and we now have job scheduling via Yarn. And that resource management that Yarn provides, it can now do that for other things, like Storm and other applications. And so Hadoop, that essential genius that we talked about of Hadoop, it lives on. That idea that we now have a fundamentally new structure for managing data, that continues. And it's better, it's real time. It's moving towards that model of real-time operational capability every single day and at different layers. And it's not just at this layer of the stack. One of the things that we've worked on as well is HDFS, which is itself not really that real time. If you've got to put data on right at once and you can't change it, that's not very real time, that's batch. So we've had to put in a lot of work to make sure that we actually re-engineer everything from that HDFS API down below and make that real time. And as part of that effort, you want your existing applications which write data in real time to be able to continue writing. And to do that, it means that you need something called a POSIX interface. POSIX interface means essentially you're writing to a file system. That's what these applications expect. A lot of the financial services companies we deal with have invested millions and millions of euros in their own applications and proprietary applications. And those things want to write to a file system. They don't want to have to write to something else, to Scoop, to Flume, to some connector, to something else that will then transport things over for you to HDFS. They just want to write it to HDFS. They want to be real time. One of the things that doing that adaptation in the file system allows is for Storm to work, for example, right off the file system. You don't need additional technology. You don't need additional connectors. That's one of the ways that we extend Hadoop to support these new modalities. So Hadoop is changing in lots of places. It's changing in the fundamental data layer. It's changing at the job scheduling layer. It's looking more and more like a real-time operating system from many regards. It's changing at the top, where we're getting real-time querying, Drill and Impala and other projects like that. It's moving more towards what we had as data warehouse, and that's very exciting to me. I haven't seen a change like this in the industry in a very long time. Let's talk about another myth. Talk about whirring elephants. So there's a sort of a feeling that within the Hadoop industry we're seeing a fight go on between the different ecosystem vendors. Sure, there's competition there, but it's important to realize that fundamentally everybody is providing to a large part the same Apache open source code around Hadoop. It's the same components for the large part. There are changes going on there. Some people have gone in and added value around management of Hadoop. Some have gone in and provided changes in the fundamental structure, how data is stored in Hadoop. Some do both. Some of that stuff is open source, some is closed source. There's innovation everywhere. That's a good thing for all of you. It's a tremendously good thing. You have different needs. Not everybody's trying to do the same thing. Some of you are large Web 2.0 companies trying to get massive scale at any cost. Some people are just trying to move over their existing data stores and keep what they had and maybe get some additional scalability. There's different needs. There's different products for those needs. That's a good thing. It's a big market. It's a growing market. There's plenty of room for everybody. Hadoop's very important in general as a technology. This is a proxy graph. I can't actually tell you exactly how big the big data market is. There's only guesses on this, even from the experts at places like IDC and Gartner. But one of the good proxies is who's looking for jobs that have the Hadoop skill set. Probably some of you in this audience. Good thing you're here. Good thing you're interested in Hadoop because it's exploding. It's an extremely important technology. And again, one of the nice things about Hadoop is everybody's got the same open source APIs and, to a large part, the same open source implementations. So it's all very standardized. If you learn that skill set, if Hadoop is where you're going to be able to use those skills anywhere. And the nice thing about Hadoop is having those standard APIs, it means anything you write to it, you get to keep. You don't have to change it. You write it once. That's a good thing. It's an important thing. It's one of the reasons that open source was an important part of Hadoop, was in order to get people to move over to a new paradigm, you pretty much always need to have open source there. People aren't going to move on to something if they think the APIs are going to change, so the APIs have got to stay the same. That's a key part of the open source message. At the same time, if you've got something you require in terms of a feature that your organization, your business depends on, well, you might need some innovations there. But you can still have standard APIs. You can still have open APIs, just with a different implementation. It's completely fine. In fact, Hadoop has already had this from day one. Things like pluggable file systems have been part of Hadoop from the very beginning. It was intended to be that way. Now, unfortunately, as you go up the stack, it starts to get more crazy. There's a lot of innovation once you start at the NoSQL layer and go up from there. That's good too. There's lots of different ways that people use data. We want to see lots of ways of dealing with that data. But it also means it's balkanized. It's not any easy way if you start with one NoSQL database to move to another. So you've got to figure out pretty carefully what you're going to start with. You don't want to do a Facebook where you start on Cassandra and have to move to HBase. You're better to start with HBase in the first place. HBase. Why did I select that one? HBase is one thing that's very important about it that's different than all the other NoSQL databases. It comes stock with Hadoop. If you get Hadoop, it's going to come with it. And that gives it a standardization around users who use Hadoop. 50% of users who have Hadoop or are using Hadoop actively are using HBase. It's got a lot of traction. It's got a strong consistency model that works typically better for what most organizations want to do with it. But it's got drawbacks too. People don't go into HBase because it's complicated, because it's flaky, it's got problems. Fortunately, there are different architectures. And once again here, you can stay with the same HBase APIs, but go with a different implementation. Implementation is not the same thing as an API. You can have a different design. If you look at the way that we've rebuilt our technology around those HBase APIs in our M7 product, we've taken out a lot of the intervening layers. A lot of those garbage collections you're going to have in Java are gone. We basically took Java out of it. If what you want is performance, you're trying to run a real-time application, you don't want a garbage collection going on asynchronously with your real-time application. You also don't want to deal with things like in-memory compactions, which slow down your application, prevent it from running. If you're trying to run a website, you can't afford to go offline during compaction. You want a graph that looks like this, where you've got the blue line. That's what M7 does. The yellow line is regular HBase. How did the application code change to move over to M7? Not a single line. It's exactly the same code, just a different implementation underneath. And that's a key thing to understand about Hadoop. The APIs may be the same, but you've got to choose the right implementation for what you're doing. And architecture is very important to what's being done. You want to make sure that you choose an architecture that supports your business. Another myth that pops up a lot is, particularly wrong, I would say amongst enterprise users is, oh, I hear about this Hadoop stuff, but all my people tell me it's not ready for prime time. This is something that is really being used by developers, the avant-garde, early stage people, early adopters. It's not ready for the enterprise, and that's simply not true. We have customers that are currently crunching tremendous amounts of data on us today, and Hadoop is not something where they copy data from one place, take data from a data warehouse, say, and put it onto Hadoop temporarily. This is something where Hadoop is the source of record for that data, is the central place where that data is crunched, where it's stored, where it's observed. And that's a key difference, I would say, from how Hadoop is usually used. You could say that the previous set of customers are really, well, they look like fancy Web 2.0 companies. I don't look like that. But a lot of people that use Hadoop are actually very stock, very ordinary companies. Here we have a major retailer that's over 2,000 nodes. They do everything from run their e-commerce websites, build recommendations from their customers, build loyalty, do fraud detection, lots of different use cases. Even things like storing video on their websites. There's all sorts of things you can use for Hadoop because it does structured and unstructured data so well at scale. Financial services company, over 1,000 nodes and growing tremendously. And they're looking at it for things like mining their own customer data for how people are actually buying things. They're looking at building recommendations. So if someone were to buy something in their credit card, they can provide them a recommendation on something else they might want. Comcast is a major American cable company. And this company is using Hadoop to, again, build loyalty with their customers. If you're a CMO in the audience, you want to be thinking about how to use Hadoop as a primary record of what your customers are doing. It should be your single source of record for what your customers are buying, what they're looking at. This is what the Netflix challenge was about. If I've got a bunch of data on what my customers have done, how can I predict what they will do? Comcast wants to know that too. So does every single media company in Europe want to know that too. And really broadly, enterprises in general want that information. Doesn't even have to be these. We can even find more niche cases. Let's talk about waste, talk about rubbish. Here we got an outsourcer. This is a company that is essentially logistics. They transport garbage around America, and they're the biggest company that does it. What would you want to do if you were that company? Well, you'd probably want to know, where are all my vehicles? You'd probably want to know, what are the weather conditions? What's the traffic look like? How fast can I move one place to another? How much is it going to cost me to deposit waste at a particular location? That's a lot of different data sources. Some structured, some unstructured. You want to know this stuff in real time. So they have hundreds of nodes that are crunching exactly this sort of data all the time. And the cost savings for them are in the millions of dollars. Let's talk about whiskey. Who likes whiskey? So anyone who's been to Japan will see that one of the things that's ubiquitous there are these vending machines that are all over the place. And these vending machines will provide you a drink of your choice. Well, a lot of these machines now use facial recognition because they want to actually determine who's buying what. It's come up in other contexts as well. It was just mentioned that a UK retailer, Tesco, is going to start using facial recognition when you go to fill up your car because they want to use that information to determine how to market to you when you walk inside the shop. In this case, this is Suntory. It's a company you might not have heard of. It's one of the biggest companies in Japan. I believe it's the largest provider, retailer of beverages and beverage services in Japan. And in their case, they're using Hadoop to actually customize products and also customize marketing around those products for their consumers. Very common use case, but a very sophisticated approach to that use case by Suntory. And we'll also talk about the Climate Corporation. So Climate Corp has been a customer of MapR for quite a while. One of the things that they do is they've spent decades collecting information about how climate changes down to a very small piece of geography. They can determine for any one location what weather has been like and what it's likely to be going out quite a long time. Lots of people want that information. I've talked to energy trading companies that rely on that information. We've just talked about a waste logistics company that relies on that sort of information. So they said they've been a MapR customer for a while. Which has happened to them? They just got purchased. They got purchased by another US company called Monsanto for $1 billion for their data. But also their sophistication around how they use Hadoop to crunch their data and do predictive analytics on this core set of information on which they are the experts. We'll also talk about Adar, which is a project in India. I don't know who's been to India. One of the things you will realize about a country of that size very quickly is logistics are difficult. Trying to do basic services is difficult. It's very difficult, for example, to deliver a service to someone if you don't have their identity. And that's a problem in India. There are a lot of people who don't have any record of their identity. And there's no way to provide health care. There's no way to provide a bank account if I don't know who you are. And so a huge project has started up. It's already at 60 petabytes to store all sorts of biometric data on people so that we can improve the human condition. And this is, it seems like a very simple thing, a very fundamental thing, having an identity, but there's so many things in our society that are tied to that. And this is another case very far away from a massive Web 2.0 site. But this is something that actually affects the human condition. It requires scale, requires huge amounts of data and huge amounts of analytics. This would not have been possible without Hadoop. Hadoop enabled this sort of an operation. and that's very exciting. And there's 500 other MapR customers today who have a number of other production use cases, and they've invested in MapR because they are focused very much on providing something that is the single source of record. They don't want Hadoop to be a copy. They don't want Hadoop to be batch. They want it to be the real-time single source of information for their organization, for their enterprise. MapR was the last to actually go to market. It was mentioned earlier by Ruben that we haven't come here before and talked about MapR, and I think that's because we entered the market fairly late, and that's because we spent the first couple of years doing innovation. We spent a lot of time rebuilding parts of Hadoop to provide the functionality that supports the customers you've just seen. But I think in terms of what we're providing, it's certainly very exciting, a difference on the market, and I'm glad I've been able to tell you a little bit about it. So thank you very much for the opportunity, and I'm happy to take any questions you might have. Oh, come on now, don't be shy. No one? Ah, okay. Please.
You said that you talk about. Hi.
Hello.
You talk about face recognition
Yes.
being used on different countries, and I wanted to ask you about. Sorry, I came running about the legal problems that can we have with that. Regarding before in one of the other speaks, somebody said talk about privacy issues.
Yeah.
Can you tell us something about legal issues regarding face recognition?
So I mean, it's obviously it's country dependent, and it depends on regulation. So every country is a little bit different on this. Some countries like Germany are very, very, very strict on this stuff. So it depends on the geography. But certainly, we see a range of adaptations in terms of what enterprises are doing with people's data, and that depends on the local market. But the fact is that every time you interact with an organization, you're leaving some sort of signature behind. And marketers have tried things for a very long time to identify who you are, whether it's using cookies, whether it's looking at web traces of what you've done, whether it's forcing you to, provide some sort of login somewhere, or whether it's all the full way along the scale all the way to facial recognition, which is, pretty much, short of taking your fingerprint or your retina scan, the most sure way of identifying you. That approach isn't going to work everywhere. I mean, not just because of regulation, but because of local culture. It's considered distasteful to do that in many places. So everyone's going to treat that a little differently, but I wouldn't want to leave the impression that that doesn't mean that every interaction will be totally private. That hasn't been the case for quite a long time. And there is a good case to be made as well that consumers actually want to be known in some cases. So it depends on the interaction, but there are cases where they would like a more tailored experience. When you log into a lot of websites, for example, you get a different experience because they know who you are. They can present information that's made bespoke, is made custom for you. And so that's a case where a customer wants to give that. And certainly there are big legal questions and cultural questions about requesting access to that data. Who gets access to it? Where can it be shared? When are they allowed to identify you based on that sort of information? When would I like to remain anonymous? These are questions that every country has to deal with, but certainly marketers are not going to hold back on collecting this sort of information, right? They're going to make every attempt they can to collect this, to buy the data, to source it somehow. So definitely, and it's a contentious issue. It's a very controversial issue, there's no doubt. But I don't think you're going to see this stopping anytime soon. The nirvana of marketing is to know down to every single individual what they want to do, and I think companies are still going to head that direction.
Hi. Some people say that MapR is a proprietary distribution, and you have some differences compared to the other distribution. How would you answer to that?
Sure. So there are differences. There definitely are differences in terms of how we do things. And it's kind of like what I talked about during the presentation, where there's a difference between the API and how you implement for that API. So one of the things that we have done is ensured that those APIs that people program to, and let's face it, everything in the Hadoop stack is today something you've got to write a script for, write a program for, write some Hive code for, or something like that, some sort of query language. So I mean, you want to stay with those standards, and certainly I would say all of the Hadoop distributions, including MapR, have adhered to those standards. To do otherwise would be to lock ourselves or lock those Hadoop vendors out of the market, which is not really a good option. So the implementation is different, and we provide innovation to the market. We provide differentiation around a number of different areas, but we don't want to change those APIs. We want people's code, their applications to continue working as they have been working, and thus avoid lock-in, right? So if you keep the APIs the same, it's not possible to actually be locked out. You're going to have a situation where you can persist everything that you have and know that you can safely do that in Hadoop over the long term.
Okay,
just one final comment. So for anyone that wants to know more about MapR, please approach me or our VP of Southern Europe, Xavier Garand, or our Head of Technology for Southern Europe, Aurélien Gouget. Thank you.